Chip Kids! Today, we're turning Purdue University into the ultimate dance floor. But this isn't just about breaking a sweat. We're about to break down how computers think using nothing but dance moves, cones, and some serious groove power. You heard that right. We're going full-on dance mode to model something called a Turing machine. So get ready to program with your feet. This is Chip Revolution. Chip Kids!
Chip Kids, you ready to learn? Let's go! What's good, what's up? I'm Miss Poe. Chip Kids, welcome to our show. All about devices, let's get locked in. Integrate chips, then we're going for the win. Fun experiments with the kids to tie in the STEM. Miss Poe teach us a thing or two with a CHIPKIDS. Let's learn.
What's up, Chip Kids? It's DJ Miss P in the house, and today, could you give us just a second?
One wrong move and I'm calling IT.
And today, we're learning how your favorite dance moves can actually help explain how computers work. Here at Chip Revolution, all of our dances are based around computer programs. It's the #1 spot for all of your favorite hip microchips. Now, I know what you're thinking. Dance moves and computer science? That doesn't compute. But trust me, we're about to spin some serious knowledge. We're going to build and act out something called a Turing machine, a powerful model that helps computers think step by step. And the best part, we're going to do it using music, movement, and a few colorful cones.
What even is a Turing machine?
Like a machine that tours the whole world.
A Turing machine is a model of a computer, but instead of chips and wires, it has a simple setup, a tape and a head. Think of the tape as the dance floor. You, the head, read the data and follow the instructions as you glide along.
So a Turing machine follows all the steps in an algorithm?
You read a symbol, perform an action, and move left or right. It's kind of like a robot DJ, reading the vibes and switching up the beat. Okay, maybe not exactly like that, but pretty close. Break it down for him, AP.
So, let's imagine an information warehouse. Inside, there's a conveyor belt lined with bins. Each bin holds one piece of information. Let's call that a symbol. The conveyor belt and bins together, that's our memory. And yep, the memory even handles the movement. Now, we need something that can read what's inside each bin and interact with it. That's where the head comes in. The head has its own little guidebook of rules. So when it checks a bin, it knows exactly what to do. Maybe switch the symbol or slide to the next bin. That rule book, that's the program telling it how to move. These 3 parts, the memory, the head, and the rules, are the essentials of any computer. So, if a process can be broken down and explained using just those 3 parts, then guess what? It's computable.
To bring our Turing machine to life, we're building a real-life simulation on the dance floor. We'll set up 4 paper rectangles on the floor as our tape. On each one, we'll stack some colorful cones. Each color stands for a different dance move.
I'm nervous and confident, but I'm ready to dance.
I can build a program, but not dance.
I'm always up for a challenge.
The Chip Kids will be the head, moving from one cell to the next, reading the top cone, dancing the move, removing the cone, and following the instructions until the program ends.
I got my sweatband on, so I'm feeling good.
Blue cone, do the fresh.
Carlton will be so proud.
Green cone, do Gangnam Style.
My favorite dance move was the color.
Yellow cone, floss.
They don't know that I've been flossing.
And orange cone, dab. which will stop the program.
My favorite dance move was the dab.
Dabbing is how you know the program is ended. That's just science. All right, Chip Kids, it's time to lace up your dancing shoes and break it down for them. Y'all ready for the remix? At that first cone, you're doing the Gangnam style. Fia, give it to me, give it to me. Keep going, Fia, keep going, Fia. You got about 3 more seconds of this, Shaylin. Let's go, let's go, let's go. Your Gangnam style. Come on, Ariana, there you go. Grab that cone, Camilo. Go to the right, let's go. You're gonna hit the fresh.
It's like you're in a video game, but like in real life.
You're gonna hit the fresh, the fresh. Hey, keep going, keep going, keep going. Good, good. Hey, go Ariana. Go Fia, go Fia. Hey, hey.
Carlton will be so proud.
Are you ready to thank him?
3 more seconds, Camilo. You got this, you got this. Pick the cone up, let's go.
These cones are killing me.
To the left, to the left. Now you are going to floss, 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 floss.
Flossing my teeth like this?
3 more seconds, Camilo. You got this, you got this. Grab that cone and throw it, baby.
I'm sick of these cones.
To the right, honey, to the right. Gangnam style. Go, Shaylin, go, Shaylin. Hey, 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 hey.
I feel like I was following like a real program, like with more dancing though.
Throw it. To the right. You are flossing. Let's go, let's go, let's go. You are flossing, Fia. You are flossing to save your life.
I have a better name. Sleep, sleep, revolution. That's where I get to sleep.
Grab that cone. Go back to the orange. And you're gonna hit the dab. Dab. Hey. Dab. Woo! Who knew being a computer could be so sweaty? But let's break it down. You just acted out a real computer process. The Turing machine uses simple steps: read, write, and move to run complex programs. In computer science, this kind of thinking helps programs run, whether it's playing music, solving problems, or powering your favorite games. Turns out, coding isn't just for keyboards, it's for dance floors too.
Okay, Chip Kids, let's kick it over to our expert.
Hey Chip Kids, I am here at Purdue University and I have Morgan here with me. Morgan, can you tell us what do you do here?
I'm an associate professor in the School of Engineering Education, and I run a lot of summer programs for youth.
Did you start these summer programs on your own, or what sparked this idea?
So my research looks at how we introduce younger kids to engineering, and I've been partnering with a number of programs on campus to work at summer camp. So I've started this to help my research and understand how we introduce kids to engineering and microelectronics in ways that excite imaginations.
Can you give us some examples on what maybe like a day in the life of a child at this camp looks like?
We try and have all our activities tailored to students' broad personal interests. So we have a lot of music-related things, video game-related things, sports-related activities where they integrate microelectronics and other engineering ideas into those activities.
And what grade levels or age groups do you serve in this program?
So the camps we've been running this summer go from age 8 years old all the way up through high school.
What year are you on with the program?
So I've been here at Purdue this is my 13th year, and I've been doing summer programs like this for at least 10 years now.
You've been in education that long?
Yes. Yep.
You still love it?
Oh yeah. Yeah, I really love watching the students kind of tackle big problems and be excited about what they're creating in the end.
Why do you feel that it's important to introduce STEM at such an early age?
Obviously, technology is all around us, and I believe that every student, no matter what you want to become as you get older, you need to know about the technology around you, be an informed user of that technology, and maybe even a developer or innovator of that technology in the future. I believe the younger you get introduced to engineering.
What are some misconceptions about becoming an engineer?
I think a lot of people just assume it's a very hard thing to do, and you have to be a math or science genius or love math and science. While there is a lot of math and science, you don't have to love it. Like, you want to be a problem solver and love solving problems, then you can be an engineer.
All right, Morgan, so be honest.
All right.
How did you feel about Chip Chip Revolution?
That was really cool. I think anytime you can get students engaged in things that aren't purely like science or math, with the dancing that they did here, is really cool. And I can tell you, we've been watching Chip Kids episodes in our camps, and the kids love it. And helps them see other kids their age doing these things, see you doing this as a teacher, and I think that's really positive for them to see different opportunities and different ways to engage with STEM or engineering.
Nice. I just love when that light bulb goes off, because we're talking about a Turing machine, and then they're like, but how does this relate to dance moves? And I'm like, but this is really simple. Like, this is science. Now tell me, how did you feel about Chip Kids being able to come to Purdue this summer?
So we were really excited to have you all come to Purdue this summer. You got to see the students in the camps, and they got to participate, which was an amazing opportunity for them. And then we have, through the Scale and Scale K-12 projects, we have teacher workshops going on this summer. They were able to see you here as well and see some of the episodes of Chip Kids. Our students saw the Chip Kids episodes and loved them. And anytime you can kind of create that whole ecosystem working with the teachers, the students, and then these informal opportunities for them to learn more about it, I think it's amazing, and I think this is great work. So thank you for coming.
Collaboration is key. Morgan, thank you for sitting down and talking with me today, giving us a little background knowledge on your summer programs. I really appreciate you for your time.
All right, you're very welcome, and thank you.
All right, and we're out. Chip Kids! That's a wrap at Purdue University. And woo, what a workout! Today, we danced, decoded, and discovered how even the simplest rules can power the most amazing tech. A Turing machine may seem simple, but it's one of the building blocks of computer science, using just a few steps to run powerful programs. I'm DJ Miss P, and thanks for tuning in to Chip Kids. Until next time, stay curious, stay loose, and keep dancing your way through science. Bye!
Let's go, it's a new kind of show that's made for you. Miss Pope teach us a thing or two with a CHIPKIDS. Let's learn.